Okay, today we're looking at chapter 4b, Venn diagrams, in our probability topic. Venn diagrams illustrates how all elements in the sample space are distributed among the events. So it's pretty much just drawing, it's a visual representation of showing where all the little bits go, I guess, in simple terms. There are a few different terms for this. So the first one is what we call an intersection. Okay, so with an intersection, there is this upside down U that we use. It's the symbol to denote intersection. And what that represents is what is in both A and B. So what do both of the sets have in common? Okay. Now, just before I move on, a couple things to note. So you need your two circles, obviously, to represent your two sets. Every Venn diagram must be enclosed by a rectangle. Okay. And also, if you have more than one set, you might have a Venn diagram that looks like that. Or you might have some going along like this. Okay, now when I say a set, you might be thinking of, I don't know, how many people like, let's just do a simple one here. So it might be who likes cricket and who likes football. Okay, so when I was talking about intersection before, the number in the middle here would be how many people like both cricket and football. Okay, and so we would go, well, the people that like cricket and football equals, and then whatever number is in there. Okay, so moving on, next one. So we've got union. Okay, and we use it with a U to denote it. So it's the upside down one of intersection. It's very important not to get these confused. So union, it means all elements that belong to either events A or B make up the union. Okay, so it's pretty much, if you think of everything A only, B only, and the intersection. Okay, everything that's inside them is what we call a union. The next one is mutually exclusive. So two sets A and B are mutually exclusive if they have no elements in common. So see how these are they're separated? Okay, that means they have nothing in common. So they're separated like that. And one last thing, we've got something called a complement. So that just means if you've got a set A, then everything that's not in A. So this is the little formula for it. Okay, so if you know, so A, so you might have something in here. So that means everything that isn't in A is on the outside, which is what we call A. And we do a little, you'll see it there, A dash. That means not in A. So anything that's not in the circle goes on the outside. And another word for that is complement. So we'll do a couple of examples to put this into practice, which hopefully it'll make a bit more sense. Okay. Oops. Right, so example 3, we're listing sets. So consider the given events A and B that involve numbers taken from the first 10 positive integers. Okay, so integers are whole numbers. And this is saying we're looking at the first 10 positive ones, so from 1 to 10. Eight, 9, oops, I don't know what happened there, 10. Doesn't like my 9. Anyway. Okay, so that's what we're looking at. Now, I'm going to try to colour coordinate this. Oh. So, A is these numbers, and B, we've got these numbers. Okay, so A asks us, represent the two events A and B in a Venn diagram. So I know we've got two sets, we've got A and B, so I'm going to need two circles. Okay, and then I've got to put my rectangle around it. I also need to label my two circles so I know what which one's which. So I'll color coordinate again. Colors. So we've got A, and then we're going to do B in this circle. Okay, so first thing I do when I'm doing a Venn diagram is look at the intersection. So what do they both have in common? Okay, so I'm going to go back up here. Looking along, they both have a 1. Okay, so I'm going to put 1 here. They both have a 3. And that's all they have in common. Okay, so I've put the 2 numbers there. Then I can kind of fill out the rest. So in A, I've already accounted for the 1 and the 3. Okay, so I've still got the numbers 2, 4, 5, and 6. So I'm going to put those in. 2, 4, 5, and 6. And in B, I've already accounted for the 1 and the 3, so 7 and 8 I need to put over here. Okay, now I'm not finished yet because what numbers have been left out? So we've got the set A and B, but we need to consider, like the question said, all the first 10 positive integers. So we've used numbers 1, 2, 3, 4, 5, 6, 7, 8. So we haven't used a 9 or a 10. So the 9 and the 10 are going to go on the outside because they're not in A. Okay, so B, that's our Venn diagram. B says list the following sets. So BI, it wants us to tell us what is in A and B. Okay, so remember from before that union means the intersection. So what A and B both have in common? Okay, now we need to learn how to do these curly brackets. So in A and B, we noticed before, or we've already written, 1 and 3. They have 1 and 3 in common. Okay, so that's how we write it. You need to write it like this. And then the next one, it wants us to find the union, A union B. Okay, so that's everything in A and B. And whenever we're writing numbers in these curly brackets, we need to write it in order, number order. Okay, so there is a 1. We know it's all numbers except for 9 and 10, so we can write those. Oops, 7, 8. Okay, they're the numbers. Cool. So let's do C. We'll move up here. C says, if a number from the first 10 positive integers is randomly selected, find the probability that the following events occur. Okay, so the first one, we need to find the probability. So we do PR of A equals. Okay, so how many numbers are in A? We've got 1, 2, 3, 4, 5, 6 numbers in A. So we write 6 numbers divided by how many numbers are there altogether? Okay, there are 10 numbers altogether because like we've been working with 10 positive integers, so 6 out of 10. Okay, and we've got to simplify that, so that's going to go to 3 over 5. Next one, we're trying to find the probability of A and B, or A intersection with B. So we've already found that down in B, and there are 2 numbers here. So there are 2 numbers that they have in common out of the 10, which is 1 over 5. Okay, so the probability that we get one of the numbers that A and B have in common is 1/5. And then last one, the probability of getting A union B, getting one of the numbers out of what's the sets A and B. So A and B have 8 numbers together, okay? So 8 out of 10, which is 4 over 5. Alrighty, and very last one, D. It says, are the events A and B mutually exclusive? Why or why not? So mutually exclusive, meaning that our sets have nothing in common, okay, but our sets do. So A and B are not mutually exclusive because A intersect B equals 1 and 3. So they have an intersection, which means they're not exclusive. Okay, so one more example. So this is an actual application that we can use. So we've got from a class of 30 students, okay, it's important to highlight or underline important information. We've got 12 that enjoy cricket. Oops. And we've got 14 that enjoy netball. Okay, and 16 that enjoy, so I'm going to try to do 2 colours here, both cricket and netball. So they're the important information there. Okay, or that is the important information. So we need to illustrate this information in a Venn diagram for A. Okay, so we've got either cricket or netball. Okay, and we need to put our rectangle here. Alrighty, now like I said before, I'm going to put a little note up here. The first thing to do when creating a Venn diagram is to find the intersection. Section. Okay, otherwise you get tripped up, and I'll show you why in a minute. So let's look at the intersection. So that's actually going to be this 6, because 6 enjoy both cricket and netball. Okay, so in the middle here we can put the 6. Okay, now let's do this bit of information. 12 enjoy cricket. Okay, now we can't put 12 here because we've already got 6 of them accounted for in the middle here. Okay, so I'm going to rub that out. We don't want the 12. We want 12 in total. So in this circle of cricket, we want the number 12. We've already got 6 there, so we're going to put another 6 there. Okay, that's why it's important to put that intersection first. And so for netball, we need 14. So we need the whole circle for netball to equal 14. We already have 6 here, so the leftover, so 14 minus 6 is 8. Okay, now we're not done because some students won't like either netball or cricket, and that's the number that we need to put it outside. Okay, and we've got 30 students that we need to account for. So if we add up the numbers we've got so far, so we've got 6 plus 6 is 12, plus 8 is 20. So we've got 10 students that haven't been accounted for, which means those 10 mustn't like either cricket or netball. Okay, and that one's done now. So moving on to B, we need to state the number of students who enjoy netball only. So that would be, let me do it in range. This 8, that would be netball only. So 8 students like netball only. Okay. And then the second one is neither cricket nor netball. And we found that already, it's 10. 10. Okay, so with the difference with this one, it just says to state the number. So we don't need to worry about any probability or any specific notation. Okay, that's all fine. Okay, and last one, we've got C. Find the probability that that a person chosen randomly from the class will enjoy. So the key part for this is find the probability. So we want to use this PR, okay? And for the first one, we want to find netball. So the probability that they like netball. Okay, so how many people like netball? Well, we can either tell from the question, 14, enjoy netball, or we could have added up our 2 numbers, 6 and 8 here, which is 14. So 14 students like netball out of 30 students altogether. Okay, now I need to simplify that, which will end up being 7 over 15. Again, guys, you can just throw that fraction in your calculator, hit enter, and it'll simplify for you. All right, the next one, we need to find the probability of netball only. Okay, so that one, netball only, it's going to be that 8 again, which we found from the previous question. So 8 out of 30 students like netball only, which will simplify to 4 over 15. And last one, we've got the probability of cricket and netball. So remember our intersection, cricket and netball. Okay, and we know that there are 6, okay, from here. 6 like cricket and netball out of 30, and that will simplify to 3 over 15. All right, so this is what we're looking at today. It is quite a bit of information, so we'll spend today and tomorrow's lesson on Venn diagrams. I'll put up the questions on our Teams page from your textbook. Thanks, guys.